Okay, so here we're going to look at long division, specifically polynomial long division. Before we do, let's throw it back to maybe third grade, fourth grade. I remember doing this in third grade with Mr. Gus. Lived up in Olympia, Washington. I remember getting that long graph paper and lining up the numbers with long division. So let's look at how we did this without a calculator back in the day. So we had 12 on the outside, and we were dividing 289. And then this process was we looked at 12 and saying, okay, well, it can't go into 2, but how many times does 12 go into 28? Well, I can fit it in twice. 3 would be too many. And then you multiplied. So we said 2 times 12 is 24. And then you subtracted, but I do not want to ever use, that's the last time I will use subtract. I always say change the sign and add. Now they're the same thing, but when we subtract, we make a lot of errors. If we add, we don't make a lot of errors. We don't make nearly as many. So change the sign. So instead of positive, make it negative, and then add these together. So we add these, and we get 4. And then what happened? We brought the 9 down. So we bring the 9 down, and then we just do the process again. So let's see, 3 is 36, 12 times 4 is 48. If I did times 5, I'd be up to 60, so that's too many. So this can be 4, and we get 48. And then we change the sign and add, and 1, and that is my remainder. So I have 24 with the remainder of 1. Or I could say 24 plus whatever 1 divided by 12 is, or 24 and 1/12 if we wanted to write a mixed number. So with polynomial division, we're going to use this long division. We're going to use the same process. So we're going to take the polynomials and divide them with this same algorithm. Now, there's a lot of tricky parts about this. But one thing you got to remember is you need to focus on the first term. So we're going to focus on the first term. And then I really think you'll find a lot more success if you think change the sign and add. Okay, so we want to divide this by this. Okay, so on the outside, we have x squared minus 3x plus 5. And then on the inside, we have 3x to the 4th minus 5x cubed. And then I don't have an x squared, so I'm going to put in a placeholder. It's not required, but in order to keep your work straight, you really kind of need it. And the same goes for out here. If I didn't have an exponent, I would put in a placeholder of 0. And then you're only looking at the first term. So we only care about how I can turn the x squared into 3x to the 4th. I want those to be the same. And so if I multiply times 3x squared, I'll get 3x to the 4th. So that's one way of looking at it. You could say, well, 3x squared times x squared is 3x to the 4th. Excuse me. So that's what I'm using. The other way to look at it is dividing. So you could say, well, what's 3x to the 4th divided by x squared? That divides to 3x squared. That's what goes on top. Okay, and then you multiply. Let's put that here, multiply. And make sure you multiply every term. So 3x squared times 3x squared is 3x to the 4th. And those are matched. 3x squared times negative 3x squared is negative 9x cubed. And then 3x squared times 5 is 15x squared. And then here is where you change the sign and add. So we're going to write it again. Change sign and add. So make that negative, make that positive, and we're going to make that negative. We'll get rid of that. And then add these together. And this now it looks more like an elimination problem you did back in the day. So these add to 0, which is what you want. These add to 5x cubed, and this adds to negative 15x squared. And then you bring down, oops, I said 5, I meant 4. 4x cubed, and then you bring down this 4x. Okay, so now we're at the process where we brought it down, and then you just repeat. So what times x squared is 4x cubed? That would be plus 4x. Or, off to the side, 4x cubed divided by x squared is 4x. And then distribute again. So this would be 4x cubed. 4x times negative 3 is negative 12x squared. And then that gives you plus 20x. Whoops, plus 20x. And then change the sign and add. So make this negative, make this positive, make this negative. And I just combine them. So that's 0. This is negative 3x squared. And this becomes negative 16x. And then you can bring down the negative 6. Bring it all the way down. And then x squared goes into x squared. So we're going to repeat the process again. This time you need a negative 3 up here. So that gives you negative 3x squared plus 9x minus 15. And then let's not subtract. Let's change the sign and add. Let's make this positive, make this negative, and make this positive. And then add those up. That's 0. This is negative 25x. And then that gives you 9. Okay, so then you have a remainder. So this x squared is too big to go into this x. We can't divide it, so it's too big. That's how you know you're done, when this exponent's bigger than this exponent. And so we can write our remainder as plus negative 25x plus 9 divided by x squared minus 3x plus 5. And so there is your answer for this long division. Now this is a very difficult problem. One, just to understand the whole algorithm, the whole process. And then 2 is to not make mistakes. I mean, I made a couple mistakes. I was able to catch them. I'm looking over here because I have an answer key just to make sure I don't make another mistake, because sometimes mistakes are easy to miss on these. So work carefully. Try this next one. Make sure you use a placeholder. You have 0x out front, and then push play and see how you did. But try that next one on your own. Okay, so up front, we're going to have a placeholder of 0x. Should I give myself a little more room? And organization is so important here. You have to be neat with your work. If you're not neat, it's going to be really hard to tell what's going on. Okay, so if I divide these, I get 7x squared. So if I multiply them, I get what I want. Excuse me. Oh, I messed that up already. I told you, errors are easy to make. That's a cubed. We just have 7x. Let's just start this one over. Should I edit that out or leave it in? We'll have to see what happens. I think I'll probably leave it in. Okay, so that was a mistake. Rather than try to, just erase and start over. It's right on cue too. I just said be careful, and that these problems are really easy to make mistakes on. Okay, so now if I divide it, it's just 7x. So 7x times x squared is 7x cubed. This would give me 0x squared. And so one thing is, like, when you make mistakes, like, just be watching for them. Like, I noticed up here, if we go back to this one, because I didn't notice until then I did x squared times x, and I was going to get x cubed. They didn't line up. It's like, oh no, I did something wrong. So just watch for mistakes as you go. 7x times 1 is plus 7x. And then we do not subtract. We change the sign and add. And then those go to 0. This gives you 11x squared. This gives you 0x. But because it's in the middle, go ahead and write it, because that'll help you keep things straight. And then if I divide here, 11x squared divided by x squared is just 11. And then make sure you distribute. So we get plus 0x and then plus 11. And then change the sign and add. Do not subtract. Subtraction will lead to more mistakes than changing the sign and add. I'm trying to say change the sign and add as much as I possibly can. So you remember, when you're doing long division, you're supposed to change the sign and add. Okay, so then when we get down to here, that's 0, and then this is -6. And so your answer is, you really could use a subtraction sign there, but your answer is this. Or maybe better would be to bring that negative out front. Oh, you can't see that. And so that is long division. So this is difficult, but if you have questions, ask. It will take some practice, and keep your work organized. So keep your work organized, and remember, change the sign and add. Good luck.